welcome everybody. I am personally, this is Doug Shoemaker. I'm personally really excited to introduce these guys, but I'm going to just make a quick announcement first. MRES, as usual, is having a participation in the eco experience at the state fair. And we're really looking for volunteers to help us out with that. It's really a great experience in the sense that you get to attend the class and learn some more things from different people and different technologies. And so anyway, if you go to the MRES website, which I know you went to get on this meeting, and just go into the volunteer category there for the eco experience, you can sign up, and that would be great. We'd love to have all. It's a free ticket to the fair and a t-shirt and a lot of fun and a lot of good company there. It takes about 140 volunteers for us to make it through 11 days of the fair. And, from morning till night, 9 to 9 kind of thing. So, please get in contact if if you have some relatives or grandkids or whatever that you think might be interested. It's a great experience for young people too. So anyway, for tonight, we're going to talk about Darcy Solutions Groundwater-Enabled Geothermal Systems. And we've got two fantastic speakers. As I've gotten to know them a little bit, they're with Midwest Mechanical Solutions. Both of them have been there a long time, from 25 to 35 years. And they're going to take us through this process of what they're doing. And it's a new type of system that they've come up with between themselves and Darcy. And what have you got? Like I think 125 or 127 wells already, and it's it's something that will really I think be of interest. So let's get them started. Randy, would you kick it off for us, please?
Yeah, certainly. And thank you, Doug, for the introduction. Hello, everybody. My name is Randy Schock with Midwest Mechanical Solutions. My teammate is with me, Bruce Barrett. He'll be talking in the latter half of the presentation. Right
Ra-
away.
Randy,
Yep,
before you start, one thing I forgot is I asked them first if they how they wanted questions.
yep,
So if you guys want to ask questions during the presentation, they're okay with that. So
yep.
just go down to the bottom of your screen and hit the raise your hand kind of thing, and we'll call on you and we'll handle questions that way. So sorry for interrupting, Randy.
No, no, not not a problem. So I'm used to it. I'm a mechanical engineer by trade, went to South Dakota State. Been doing HVAC sales, like you said, for 26 plus years. Uh, Here's my contact information along with Bruce's contact information. If anybody has any questions or thinks of any questions after the fact, feel free to email Bruce or myself. More than happy to answer any questions. So want to introduce you guys to Darcy Solutions. And I don't know how much if any of you have read into Darcy Solutions, but it's a new take on geothermal that's really unlocked the ability for sites that used to not be able to do geo because they didn't have enough property, and we'll talk about that here later on, to now with this technology, there's buildings that are in tighter urban areas that are now capable of doing geothermal with some pretty high capacities. So, what is Darcy, or who is Darcy? Darcy started back in a couple geologists at the U of M, a couple local guys, Scott Alexander and Jimmy Randolph, both at the U of M, professors there in geology, had been working on this technology forever. And what it is groundwater-based geothermal systems. So state of Minnesota, we are blessed with tons of aquifers below our feet. And how the technology works is that we are shoving or installing a heat exchanger, and I won't go into a lot of details, but just think of it as a heat exchanger that resides down in the aquifers, like around Minneapolis, southeast, Minnesota here. We have two major aquifers. It's the Jordan or the Prairie du Chien. And it ranges anywhere from 300 feet to maybe 450 feet below our feet. And we put a good sized heat exchanger down there, which allows us to get some really high capacities. And we're not drawing out any groundwater. This isn't like a pump up to the surface and re-inject it back in. We're not doing anything where we simply have a heat exchanger down in the aquifer that we exchange heat with. And then it's a closed loop that goes between the building and to that heat exchanger. And with that single heat exchanger, we're with a single well or a single heat exchanger, we're able to supply about 200 to 250 tons of cooling to a building. And with that same heat exchanger, we're able to supply ballpark about 1200 or 120 MBH of heating to a building. So that's really been the game changer with this technology. And I'll stop there if anybody has any questions about it, because like a typical geothermal well, and we'll talk about it here uh, later on, but a typical geothermal well, you're only about a ton and a half, maybe 2 tons of cooling per well. And here we're doing, 100 times that.
Kim, go ahead.
Thank you. Randy, give our group here a little comparison to something that we relate to. Like, well, how many square feet can that heater cool? Or can you give
Okay.
us a sense of like what we're talking about compared to, say, a HVAC system in
So,
your typical
yep,
house?
yep. A typical and houses residential versus, I'll go residential first. Residential housing, you're usually sizing a house around um, a ton of cooling will usually cover about 1,000 square feet of house, ballpark. In the commercial space, depending on lighting, density of people, computers, lights, and so forth, you're in that 400 to 600 square feet per ton of cooling. So, 250 tons, that is uh, quick math, 250 times, just call it 500. That's a 125,000 square foot facility
Wow. On one well?
with a single well.
Wow. What's the diameter of the pipes
That
you have
that
to
heat
use?
exchanger on that, and we'll talk about that later, but the typical one that we utilize today is a 12-inch diameter heat exchanger. It sort of looks like if you know what a shell and tube heat exchanger looks like, it looks like a big tube bundle that we're shoving down in the aquifer.
Cool.
And that's
Thank
what's
you.
given us the ability to unlock geothermal in some higher density areas. Areas that typically could not do geothermal are now have the capabilities of doing geothermal. And I have a slide
Right.
here later on that shows that. So the real advantages of the Darcy system are, like I said, it's a very small footprint. It looks like a municipal well. It sticks up above the ground 24 inches. People sometimes cover them with rocks and such, but it allows us to put a lot of capacity in a very small area. So that's one big advantage. Another advantage is the unbalanced loads. The aquifers here in Minnesota, depending on southern half or if you're a little bit further north, our aquifers are always 52 degrees for the most part, plus or minus a degree. There's a little bit of drift in there. So we have, it's not like traditional geo where you're sort of pulling heat from the ground and then you're trying to put heat back in the ground. Traditional geo uh, is conductive, so it's like charging or discharging a battery. Here, it's like having almost an unlimited battery source. We've even looked at the idea of applying smaller data centers to this, right? Because there's underground gradients, or think of what they call gradients in the geology world is underground rivers, where that water is always moving. And we'll talk a little bit about that later. And then,
Randy, I was going to ask a quick question later, but I'll just ask it now.
Mhm.
Have you guys looked at all? Because I'm reading and I'm seeing that there's some systems like this that are actually starting to produce electricity and heating for like buildings and electricity. Is that something you guys have looked at all or?
I'd be curious in the technology on the other side of that. So like again, that groundwater temp, if there was no load, if I back up one slide, if there was no load on the building here, if you can see my mouse, I don't know if you can,
Yeah.
and we
Yeah.
just allowed this ground loop, you know, if we allowed there's a pump below the heat exchanger, and if we allowed this loop here to run, it would eventually equalize at 52 degrees,
Hmm.
right? And then as we're trying to put heat into the ground, that temperature rises a little bit in the loop, but again, the aquifer water stays very consistent. But so I'd be curious in the technology that you're looking at. My gut tells me it's probably something to do with the organic Rankine cycle. You and I were talking a little bit about that the other day.
Yeah, I think so. And it's amazing. I mean, one group is talking um 18 megawatts and another group is talking over 500 megawatts. They're working on it. The ones I saw were in Germany.
Yeah, and I wonder if that's more of like if they're drilling really deep and getting into like to the thermal energy, is that Ireland,
They're
Iceland, or
actually
Greenland?
getting into super deep layers of the earth, which are hotter when you
Yeah,
travel a mile, 2, 3 miles down. We're much shallower
yeah,
than that. Even
How,
like places like Greenland, hot spring areas,
yeah,
they absolutely leverage heat out of the ground for generation of electricity.
that makes total sense. So, well, anyway, please. Oh, Chris, you got a question?
yes, I have a question. I think I maybe missed something, but so are you saying that it takes heat from the water in the aquifer and so it doesn't recirculate, it just ejects it back down into the aquifer?
yep. The water never leaves the aquifer. So let's just say our heat exchanger, like we have one at our office, and anybody in Minneapolis, if you want to come and see it, you're more than welcome to come to our office. Our office is in Golden Valley.
Okay, so
Uh,
it comes into the building at 52 degrees, is that what it does?
so the aquifer water, if I wish I could zoom in. This aquifer water, if you can see my mouse at the bottom of this
Yeah.
heat exchanger, is probably right around 52 degrees.
Okay,
And
so
then
it,
as
go
in the
ahead.
summer, in the summertime when we're exchanging heat, the water is leaving the top of this heat exchanger, so it stays down in the aquifer. It's maybe about call it 55, 58 degrees. And now this underground aquifer is like an underground river. That water is always moving. So we have a separation layer between where we pull in water into the heat exchanger and we discharge water out of the heat exchanger, and that's how we maintain the separation.
So how does it when it leaves the aquifer at what temperature and then it's returned to the aquifer at what temperature?
We're not pulling any water out of the aquifer at all.
Okay, you're just taking the heat out of it.
Correct.
Yes.
The water, we never pull any water to the surface.
Uh-huh.
Because when you pull water to the surface, there's a whole other slew of issues you have with what they call pump and re-inject. You got your dissolved solids, and your dissolved oxygen that'll
Okay.
come out of the water. You'll get your calcium carbonate. So if you pull any water up and you want to inject it back in, you got to keep it under pressure.
I guess what went through my mind is the question. I worked on illustrations for how, coal plants work and stuff like that.
Yep.
For the water, they take water out and they eject it back into the river and it's
Nope.
hotter or colder, it
Nope.
affects
We
the
don't we
environment.
don't pull. That's the great thing about Darcy is that there is no water coming out of the aquifer. Everything stays in the aquifer.
Yeah, the Minnesota Department of Health has made it very, very clear that they want to protect the water in Minnesota. And they will not even allow us in the red and blue pipes that Randy has in his picture there. They will not even allow us to put glycol in that. So it's environmentally friendly in that we're not removing any fresh water at all, and we're not in a risk position to put glycol should there be a leak in those pipes.
Yeah, the water in the red and blue pipes is what they call NSF 62. It's potable water rated.
Yeah. Okay.
Wow.
Yeah, it's super technology. Wow.
Potable water. And
Yep.
interesting. So it doesn't freeze as they get close to the surface.
No, we keep it all underground. Like our lateral pipes coming into the building, we keep it below the frost line at 7 feet. So
Okay.
we'll punch into a building below the frost line, and then we'll come up.
Guys, that's
Oh,
me saying we better let Randy continue on to the next slide.
No, not a problem. This is all great, everybody. If we need to come back and do a second half of this, if we don't even get to Bruce, that is fine. We can do this another time.
No, we got to get to Bruce.
So the total cost of ownership, it's very high efficiency. Again, since we're running against 52-degree groundwater, we can size these systems for unmatched efficiency. We have some geo systems in town with the help of a little bit of solar. They're running near net zero. Case in point is Lakewood Cemetery there in Minneapolis. That's one of our more recent jobs.
Hmm.
So this slide's just showing us the difference of the left. This is your typical geothermal where you run two pipes up and down in the ground. It's not in the aquifer, and you're exchanging heat with the ground. And that's where I'm saying traditional geo, you only get about 2 tons-ish max with traditional geo. And there you're running a glycol solution, where on the aquifer-based geothermal that we're showing off to the right, we're actually using that groundwater as our heat exchange median down below. It's still separated. We're not pulling again any water out of the aquifer. All that water is staying in the aquifer, and we have a closed loop heat exchanger. So it's like a shell and tube heat exchanger that we literally put down into the aquifer. So if you look at that, this is an example of a traditional bore field versus what we would be with Darcy water. And look at the amount of space that traditional bore field would take up versus what we could do with 4 wells. And we're showing this because we have this example over in St. Paul at the St. Paul Pipe Fitters, where
Mm.
they were going to put in a traditional geo field. They were going to have to rip up their entire parking lot. And we said, okay, time out. We can put these wells along the edge of your parking lot, not even mess with your parking lot, and will give you just as much capacity, if not more.
Awesome.
So that's really what we're trying to point out there is the amount of, and that's what's really unlocked it. Our office, we're about 30 tons ish of cooling in our office. We would have never had enough room for traditional geo. We would have ripped up all of our parking lot, and we're in a pretty urban setting there in Golden Valley, where now we have one Darcy well that's about 5 feet from our building wall. So that's our motorcycle parking, and it works out great.
So how deep are you guys going?
So it varies in Minneapolis. I'm sure everybody's all over, and we have projects around the country, but since Darcy started here in Minneapolis, most of our projects are here. Like stuff up by Maple Grove, Boston Scientific's building a new building up there. I'm doing Maple Grove Ice Arena. I'm about 250 feet there. Our office is in Golden Valley. We're about 300 feet. I'm working on Sabathany Community Center right now. That's in South Minneapolis. We're about 450 feet. Excel Energy just built a new service building over in St. Paul at the old, is that
The
highway?
heights. The heights. That's
Yeah.
one I wanted to ask you about.
Yep. So I worked on that one in the design side with TKDA. Bruce has been there numerous. That was a big site. That's got 12 wells, and it's mostly for heating, not as much cooling. It's mostly for heating.
Okay.
Um, but there, Bruce, you remember were we like 475-ish, 480?
Right in that range.
Yeah.
And is that just for that big building for XL, or is that for all the houses that are in there?
No, just the building.
Building.
And it's really because of the outside air required when they fire up all their trucks. They got to bring in so much outside air. It's a big heating demand.
Yeah. Uh,
You've got a lot of underfloor heat, and I don't know how many trucks that building can hold. 100? I don't know. A lot.
So
Massive building.
So this is a typical schematic of a Darcy system of what everything in red is what we provide. We try to provide a turnkey system. So we're providing the wells are down the ground, we're drilling the wells, we're running the laterals into the building. And that's where the mechanical contractor takes over and pipes it into, and it's whatever can be water cool, whether it's a water to water heat pump, and we're making, and Bruce will talk about this later, of what the systems you can attach to it, or it could be what we call a VRF system, or it can be a distributed water to air heat pump system. But we try to provide a turnkey package, less the high voltage wiring and the low voltage control wiring. We let the local contractors handle that, but we stub it into the building and handle all the control devices, and the contractors take over from there. So that's sort of where our line of delineation is between what we're providing and where the mechanical contractors step in.
Okay.
And we have a very, proven process. Again, I didn't mention this earlier. Darcy started doing commercially, like that 455 building was probably right around 2021, 2022. And we've slowly, we stubbed our toe a few times. It's a growing company. We're learning, but now we've developed this very, very good proven process. You have a site you want us to look at. We do a quick site assessment. And the key to that is the geology. Having the geologists, and we have some of the best geologists, we feel, understanding the geology and what that site can support. And the thing we've learned, and we'll talk about that later, is the geology from where your feet are standing right now to less than 100 feet away could be completely different. There's been some sites where, and we'll talk about it, where there's underground rivers and valleys, and that's been the difficult part, is that there's no map of what's below our feet once you get below 35, 40 feet. What we call Revit in the engineering world. There's no CAD file of what's below our feet. So that's been the hardest part, is understanding what's below it. But then we'll do some development support. We'll sometimes do on-site testing. And there's a few different methods of testing we can do. We can do where we'll shoot down an echo, basically do like an echo of the land. We can sort of see what's down there for geology. We can do a test bore, or we can do a test well. And those test wells can help us determine the best technology for that site. But we'll go through our steps of project proposal. We'll do our construction execution, and then on the tail end, doing full-blown service contracts at the tail end. So Darcy is a full, I'll call it turnkey provider from, beginning to end. They want to take care of the life of that customer.
Is there other states that you guys see good potential, or are we kind of unique here?
We are very lucky to hear. So this is a map of everywhere that we've looked. So
Okay.
the red dots are jobs that we've actively done. So we have a job out in Wyoming. We have some over near Chicago. We have some down in southern Indiana, right? Now, all the pink dots are areas that we've looked at.
Okay.
And some of these, and again, the concentration of them are in Minneapolis, because that's where we started. And now, as Darcy, I'll speak for Darcy. Darcy is slowly growing their rep network. So Midwest Mechanical, we're the manufacturer's rep for the Darcy Solutions project. We're out there talking to owners, engineers, contractors about this. As Darcy develops that rep network around the country, we'll start to see this, map populate quite a bit.
So I had a quick question.
Go ahead.
Randy, do you come out and do that initial site assessment stuff for free, or what
Yep,
are the
yep.
costs
So the initial
associated with
site
the building owner
assessment,
to do that?
yeah, is free of charge. So it's a geology review. You give us an address. So
Mm-hmm.
here's some of the buildings that we've done, right? Whether it's at the airport, a lot of schools, a lot of public buildings, healthcare, uh, I'll call it high rise, residential. That U of M OCF, that's their records facility. But it starts with, you give us the address. We have to put our geologists on it. They look at the geology of the site. That's step one. Sometimes the
Cool.
geology is thumbs up. We don't have to do a test well. Other
Okay.
areas, when we get into certain areas, like it's a little iffy, We either want to do like a seismograph type thing. I don't know if I said that right. Um, Up where the old arsenal used to be in the north side of the cities, I forgot what they call that. Uh,
Yeah,
we're gonna, and there's some
Yeah,
contamination
Arbor,
there.
yeah, Arbor, what is it? Yeah, they're trying to make it into like
a
Yep.
Arbor
creek. It's
Yeah,
it's
Rice Creek. So we
creek.
just
Yeah.
put we just put a building there that has two Darcy wells. We did a test well there. Um, they're going to come back and build another building just to the south of that one. Even though it's only 100 feet apart, there's an underground valley there that's 100, 300 and some feet down that you don't quite know where it's at. So we're going to try, seismograph isn't the right word, where we're going to shoot some radar down and try to see what bounces back, right?
Hmm,
Um,
cool. Okay, and then once you yeah, so to an initial assessment, you guys can come out and look at a building and
yeah,
blah blah blah. Obviously, there's a lot of stuff about the building and its heat and whatever load, and then you can look
yep,
at like, hey, this is the parking lot-ish area we could put it in, and you then
yep,
do
yep.
a
Yeah.
set an
So you
assessment,
really
and you
click with
can
the
kind of
address. Yeah.
give it a thumbs up or thumbs down before you really spend any money.
Yep. Yep. Yeah. Because there
Cool.
are some state places in the state, like you get in the Iron Range, uh,
Mm-hmm.
that's a no-go. There's some
Why is that?
places
Because
up
it's
in,
all granite or something?
yeah, there's some places, because you just hit rock right away, right? You can't, it's hard to drill through
What are you giving up so easy because you hit some rock? I'm kidding.
it.
No, I'm kidding. No, there's a reason it's called the Iron Range, and it's probably also
Yeah.
because the rock is as hard as iron as well.
Yeah, yeah. There's some spots in St. Cloud, that have been a little spotty. It varies. You look at some of the maps of the state, it's sort of interesting. Um,
Randy is your biggest potential market. I know it's could be any larger building. Is it schools? Are they a big market now?
it Schools are a big market for us, but it's really anybody. I probably have at any given time, I probably have 10 active jobs going on with probably another 20 in the coffer of people just talking about it.
Okay. Hmm.
And it covers like what you see here, the airport to schools to the public sector to the university to healthcare. Everybody's really been we can use it on anything that needs heating and cooling. We can use it on anything.
Yeah.
And again, it's that the smaller systems become a little bit more difficult because if you were say you're only 10 tons, that's where you start looking at community systems. And if you let's just say you had 100 houses and everybody wanted to hop on it, you'd have to figure out some type of community system where you could do geothermal energy to all those houses, which
Yeah.
would take a lot of piping.
Kim, I think in that area you're working would be great potential around there.
Yeah, no, I'm going to be talking to you soon, Randy, because I'm working with the Public Housing Authority, Textile Center, and Prospect Park Properties owner Jeff Barnhart, and they're
Yeah,
all interested in doing
yeah,
geothermal. Well, Textile Center, 15,000 square feet renovation, new buildings already. I can't say this publicly, but they're very close to giving it a thumbs up.
yeah.
But I wanted to ask you really quick, are you like an exclusive contractor dealer for Darcy in the community, or is that how
Yes.
it
Yep,
works?
yep,
Like
yep,
like
yep,
geography gets a certain
yep, yep.
area, kind of
Like
like
in
how the old car
Wisconsin, there's a
dealerships and
rep over
stuff
there
too.
called Glacier, and we have South Dakota, North Dakota, Western Wisconsin, but you get further into Wisconsin, it's Glacier. I think if you get over by Chicago, it is Windy City. So they're basically setting up rep networks like us around the country.
Got it. Okay. Just wanted to make sure. Yeah, we'll be in touch. Thank you so much.
Nope, not a problem.
Powerside Innovation District we tried to do it. We were very close to doing a district energy system using actually sewer wastewater from Metro Council because we got a massive, like 12-foot diameter
I've
sewer
I,
line
I, I've
50
looked
feet
at that. So
long.
that the other side of, I do HVAC day in, day out. So working with District Energy in St. Paul with
Yeah,
Pig's Eye,
that's
we
what
were
we
trying to
did.
use the effluent water to run a heat
Yeah.
pump in reverse and pump it back up to St. Paul.
Yep, that's what we were going to do in Tower Side. We had the financing stack all good to go, but Unfortunately, it was in the spring of 2022. It was March, and we had the anchor tenant with the 750 units of new housing had to pull the trigger because all the financing people were freaking out. And guess what? June 1st, the interest rates were at 7% from 3. So
Right.
had he not done it, he wouldn't have actually gotten it off the ground. However, we missed the opportunity, you know what I mean? The window snapped
Right.
shut. So we're going to go at it again. I'm working with public housing, like I said, and other people. I'll be in touch. Thank you.
Not a problem. And I'll try to speed up a little bit because, the total cost of ownership brought up earlier. The one thing I forgot to mention is what really drives that total cost of ownership of these systems is the IRA tax credits. And Bruce will talk about that later.
Yeah.
But there's a lot of ITC IRA tax credits that not only apply to your geothermal property, but applies to all the HVA equipment in your building and the labor, and the install cost and everything. So there, a lot of these geothermal projects, even though geothermal is, I'll call it more expensive when you look at it from a, hey, I'm going to put a bunch of wells in the ground. When you apply all the tax credits that are available today, it's actually a wash, and or in some cases it's been a net positive. It's actually been cheaper to put in the geothermal than a traditional heating and cooling system. So I forgot to mention that. I just wanted to bring that up quick.
Barbara, do you have a quick question?
You're on mute, Barbara.
You're muted, Barbara.
So you have a heat exchanger down at the bottom there, and you're either withdrawing or injecting heat. But there may be a river running through the aquifer there. But it must have some effect on that. So what is the radius of your effect, say, if you're in the heating system of cooling the actual aquifer then, when you're withdrawing heat?
So where, just ballpark, not exact numbers, but ballpark, like where we draw from at the bottom of the heat exchanger to the top side of our heat exchanger is somewhere around 40 to 50 feet. And we have a layer of separation there from different technologies of what they call a Lemco seal or a Packer seal. And then when we space wells by each other, when we have multiple wells, we like to start at 100 feet apart. So that radius of influence that you're talking about,
Right.
within 100 feet away, we're really good. Like Sabathany, I'm at 65 feet from wellhead to wellhead, and I don't have any crossover between the two.
Thank you.
Yeah, thank you, Randy.
Nope,
Yeah.
not a problem.
Kind of further to that, the mass of moving water in the aquifer is beyond your comprehension. There's no risk of us cooling or heating the aquifer en masse. It's simply going to be 52 degrees forever. Billions and billions and billions of gallons below our feet.
Yeah. So, topic of this was what have we learned in our first 100 and some wells that we've poked into the ground? A lot of great things. And like I said, a lot of learning lessons right away. We've really streamlined it now. Really focusing on geology. This technology is all based on geology. If you don't understand geology or you don't have people that understand geology, you're going to run into a lot of problems. I talked about the site up at the old munitions site, this buried valley. We never even knew that thing was there. We have two wells that are, call it 75 feet apart. One of those wells, because the valley was right there and we didn't know about it, we had to drill that well another, I don't know, 50 or 100 feet, unknown to us, but just to get into the aquifer. So like when we drill the well, we video log, what they call video logging the wells. We'll run a camera from the top all the way to the bottom and log every foot. We know everything that's in that well. So that's that having great geologists, and we have, like I said, we have the best geologists. We have 12 of them on staff and hydrologists. When they're out there drilling, this is a photo of a drill rig. I think that's Butterfield's drill rig. They're out there sampling material as it's getting pulled up, and they know exactly, oh, where in the sandstone, and I'm talking out over my pay grade if I'm talking geology, but they understand every layer that we're drilling through. But having these geologists on staff, along with our great driller network that we've developed. We have about a half a dozen, guys that are drilling for us. In these wells that we're drilling, I mentioned this earlier before the prezo started. When we're putting a 12-inch heat exchanger in the ground, we're drilling a 20 to 24-inch hole. That's how big the hole is going down. There's only about 6 to 8 well drillers in the state that have that type of drilling capability. And we feel like we've teamed up with the best ones that do that. And without them, we'd be dead in the water. So,
so to speak.
yeah, yep, so to speak. We talked about pilot wells early. We found out that either, and I know I'm saying this wrong, doing the seismograph, that's a little bit newer technology. Like we're always developing technology, but doing these tests upstream before we start drilling, especially in a multi-well site, it can help us save money because if we don't know what's below our feet, because there is no map of what's below our feet, we'll drill a pilot hole. We'll have the geologists there, and they say, "Oh, the map said it was this type of layer, but we actually hit bedrock or whatever at this level, and it's open hole." And it's helped us lower the cost of the actual drilling. So, drilling these pilot wells isn't cheap, but we make up that money and then some when we do it, if we're unsure of the geology. So that's something that we've learned. And then a recent development is we've now said, okay, if we're gonna drill this 6-inch or 8-inch pilot well, we used to abandon those. Now especially if we go to 8-inch, we can actually reuse that well and actually make that a production well.
Hmm.
So there's ways that we figured out how to save costs in that. Not all the time, but sometimes we're able to reutilize the well. It's not every time, but sometimes. And again, it's all geology dependent. Well development. This was we say the 12 well system, but this is actually the Excel site. We've developed, or Darcy has developed their own tools for well development. So after we drill the well, there's a lot of crud, I'll call it, down in the well. So when they call it developing the well, it's like cleaning the well. And there's different ways of doing well development. There's airlifting, or there's all these methods that the drillers use. Darcy on their own has came up with different methods to ensure, because we want to get that water crystal clean before we shove a heat exchanger down there so we don't have fouling issues. And within that 12 well system that we did over at Excel's building, one well, we could develop the well and get the water clean in, our normal process is maybe within 24 hours, we got that well clean. There were some of those wells, we spent 10 days developing the well, trying to clean it up, and like you pull water to the surface and like you're trying to get all the sand out. If I could show you Sabathani, if anybody wants any nice beach sand, I mean, we've got piles and piles of sand just sitting there that we got to haul away. And that's sand from 450 feet below our feet. I mean, that was their dinosaur days.
Wow.
So
you can't drop a super sucker hose down there, huh?
No. So this is what we call when we say well development. So the left picture here is prior to well development. You can see, like, so this is what it looks like down there. Like there's fissures all over. It looks like a sponge. And if we were to shove our heat exchanger down in this left one, that sand and dirt would get sucked into our heat exchanger and it would foul up right away. So what we try to get it to look like is the one on the right, where that looks very clean. It looks like nice, clean rock. We're not, now we put our heat exchanger in and we start moving water around. We're not going to get any of that stuff stuck into our heat exchanger. So that's been a very big development, is how we develop these wells. Controls optimization, just how we run our systems from an efficiency standpoint, especially in a multi-well scenario, how we stage up and stage down as buildings are loading. We used to, in the commercial building space, you have all these controls contractors that control the building. And we used to let them control the pumps that feed our Darcy wells. We took over that just because it seemed like every job we were working with a new controls contractor, and they just never understood exactly how we wanted to optimize our system. So now we've just brought in the skills to handle everything that is on the geothermal side. We say, okay, this is the building loop, and we separate the Darcy system. I told you earlier, those water pipes are potable water inside there. We actually separate that loop typically with another heat exchanger inside. So the building is on their loop. We have our closed loop, and then you have a heat exchanger in the ground. So there's multiple layers of protection so we don't contaminate an aquifer. That is our biggest deal, is that we don't do any type of contamination. We don't bring any water to the surface, and we're not going to contaminate that aquifer water. So we try to keep the building loop on its loop, and our closed loop is our closed loop.
Does PCA keep an eye on you guys, or?
We're always working with the MDH, so the Department of Health pretty much looks at everything that we do. So like all of our permits and everything is through the MDH.
Okay.
So this is just like a typical mechanical room on the commercial side. You know, what our pumping system looks like and what our controls platform looks like. So
Awesome.
You know, and now, you know, we've seen a little bit of this where geothermal, a lot of people look at geothermal and they look at first cost, and that can sometimes be a deterrent. And the ownership and operational costs and maintenance costs. You know, people say, well, geothermal can be expensive. When looking at that total cost of ownership, so you have the cost of your geothermal going in, we look at the incentives, like, hey, Mr. Customer, what can you guys get for incentives from, you know, either the IRA, ITCs, and so forth. But what Darcy has also done said, hey, you know, Mr. Owner, you guys don't want to take this on. We are also where they're now starting an asset management service. So now instead of you guys getting, you know, or a customer getting a big first cost chunk hit, Darcy will take that on and spread that out, you know, so it's basically coming out of your OpEx versus CapEx.
Okay.
CapEx or capital expenditure, you know, let's just say it was $2 million to put in a geothermal system. Well, instead of that, we'll spread that out over X amount of years, and now it just comes out of your annual operational cost. Does that make sense?
Yep.
It does, but that's a huge statement you just did. This has never been done before. I mean, we know all about solar and wind and the 6-year flip and the tax credits and how you have to have limited partners, the whole 9 yards. So what I just wanted to clarify here, you're saying that Darcy is putting a finance division together to basically
Yep.
like lease your car to you, just like, I mean, lease
Yep.
the Sims, lease the car. It's like leasing a car from GM.
Correct. Yep.
You're saying you're going to build it all out and we'll lease it more or less for the
Correct.
payments of the energy?
Yep. It's just getting
Okay,
going. We just announced it here in June.
It's
When do we
June,
have our
right?
proposal? End of
Yeah, I've
May.
never heard of that. No
Yeah,
one's
middle of
ever
May.
done that.
Middle of May, we announced it, and I think we've proposed maybe one job so far, but yeah, they're bringing on the financial resources inside to bring that into your OpEx versus your CapEx.
Okay. Well, that's really wonderful. Yeah, no, I think that's great. I just was talking with folks from yesterday about this from Peter Greenberg from the CFO of the MNCFA, the Minnesota Climate Finance Innovation Authority, the Green Bank,
Yep.
and also Holly Houston, who is the CFO of St. Paul Port Authority. And they were the two people that were in charge of putting the financing together for the Heights. And
What's his name? Left, went over to MNCFA from I forgot his name.
Monty Heil, Monty.
Monty Hillman is now part of he was actually in our office doing the presentation here at the end of May for
him and Asa. They were Monty wasn't there because he was in Montreal, but Asa, who's from that same consulting company, I'm sorry, I don't remember the name either.
Yep.
He was at this meeting yesterday with the city of Minneapolis, hosted with GPI coordinated, but it was paid by the city.
Yeah. Some of these slides were
Anyway,
actually
they were
from.
there, and we had a whole meeting on like, well, okay, we got to figure out. It's like putting together low income, tax credits with this and that, and like building low income housing. Got to have this capital stack, and that's been always a big barrier. So man, oh man, if you, and every I was sitting there with all these people, including like 5 different low income housing developers and like 3 different finance people and people
Mhm.
from LHB architects and stuff. Nobody said there is a turnkey finance solution that someone could do. Because if that's the case, that makes it, as you know, the biggest barrier was upfront cost on this stuff. That just you have to
Exactly,
finance it
and
up
that's why
front.
they're bringing it to market to
Yeah, thank
again
you. This is
take
so
away that
amazing.
hurdle. And again,
Right.
Bruce and I know enough about the finance side of it to really get ourselves in trouble. Like we always say, from a tax standpoint, talk to your tax consultant. We got a few slides. We know enough to be dangerous, but Monty Hillman is sort of our go-to whenever we need help.
Awesome. He's a great guy. Yeah.
So yeah, and Darcy Solutions is an asset management. You can apply it to any type of building. So this is what we're promoting here. It can be any type of building, it can be government. You can go into lower right there is the Lakewood Cemetery, and we're just showing examples of what you can and can't apply it to. But it's pretty much any type of building. You could Darcy as a asset management solution. You could utilize it.
Awesome.
Technology advancements. So um, over the years, like what's installed over at the local 455 is the either a 6-inch or an 8-inch heat exchanger. We weren't, I think we weren't getting a lot of capacity out of those. And then just over the years, Darcy has developed their technology, understood what works as a heat exchanger, what doesn't work as a heat exchanger. So over the years, developed new heat exchangers. So these are the BTUs we could get both heating and cooling. 2025 is sort of where we're at right now. This 1200 MBH of heating, 2780 MBH of cooling, which puts us right around 220 tons. And you can get more out of that one. And we're really excited about what's coming here down the pipe. You see an 18-inch here. Uh, I've seen some preliminary runs of that so far, talking around maybe 350-ish tons out of a single well. Uh,
Wow.
so that's something we're slowly working on. And again, that is geology dependent. You got to have the geology to make that thing work. So it's not for all areas, but if you have really good geology, it's potential. Uh, Darcy used to do their testing at the is a U of M lab. I forgot the name of it, but they're putting together their own lab so they can start really testing their own heat exchangers, developing the next generation of heat exchangers. So this is really going to help us set ourselves apart and help the technology grow.
Hey, Randy,
Yes.
quick question on technology. Oops. I
Yeah,
was
go ahead.
just
Back
looked at
up.
the next. No, I was just looking at the next slide. Maybe that's where you're headed. Just for technology understanding, you've got a heat exchanger down in the aquifer.
Yep.
You have a closed loop system that circulates a fluid, we'll say, but then the heat pump that's actually in your mechanical room is a pretty conventional heat pump in the building itself.
Correct. You can do, and Bruce will talk about that later about the systems, but you can do water to water heat pumps. So where it's a chilled water, hot water. So we're sending that around to commercial buildings. You can do what you see in the residential space or some office buildings is what they call distributed heat pumps, where you got the heat pump above your ceiling, and that's a water to air. So you could have that in a residential or an office landscape. Our office is what they call VRF, it's a water cooled VRF system where the compressor side of it is cooled by the geothermal, and then you're moving refrigerant around. And there's some advantages to that because now the refrigerant will just toss the energy back and forth between rooms. You don't even have to send it to the geothermal. So we just did the Friendship Village down in corner of 494 and 169. They're all VRF down there for that senior housing down there. Our office is VRF, and I think there's a few other VRF offices that we've done. So We talked about the ability to get a bunch of density in one spot. This is something that we haven't done yet, but we could hit two different aquifers. You know, if we know that the Prairie du Chien is at 300 and some feet, there's an aquifer called the Saint Marie, I think it is, that's about 600, 700 feet. So it's at a different layer. So now we can actually put two wells, or what we're calling nested wells, side by side, and we could hit two different aquifers. So that's another way to get more capacity out of a landlocked scenario.
Wow.
You know, the sensors, you know, when we first started off doing this, we weren't measuring a whole lot of stuff. Now we sensor these things like no tomorrow. We have multiple sensors on the incoming water in the aquifer, what's coming out, you know, what's leaving our heat exchanger down the aquifer. We have pressure sensors, temperature sensors. We understand everything that's going on down the aquifer, and we monitor. All of these installations are monitored live for the most part, as long as the customer gives us access. We can see all of these systems live. So just the advancements and the control improvements that we've done over these first 4 to 5 years has set ourselves apart. And then again, this is just talking about all the components. You know, here we're showing. I mentioned this before. It was called the Lemco seal. That's how we tried to maintain the upper well, like where we inject back in, versus the lower level where we pull water in. Sort of what you see, this balloon-looking thing, is what they call the Packer seal. It's actually just looks like a big balloon. After we lower the heat exchanger down into the aquifer, we blow up that balloon, and that's what creates our separation area, so we don't recirculate water right in our heat exchanger.
Hmm.
And with that, I come to the end of my prezo. Any questions? If not, I can let Bruce take it over. Looks like I chewed up about 50 minutes, so you might.
One quick question. Have you guys ever been down to Prairie Island and seen those big wells that they run down there? And it's like one aquifer to another one, and that's a open loop system, and then they put it into the building.
Yeah, so at the casino down there,
Yeah.
the casino is allowed to do things that the rest of us can't do.
Oh, okay.
They're a sovereign nation. So that's a pump and re-inject system. So like where you pump water up, you bring it to the surface, run it through a heat exchanger, and then you got to inject it back down in.
Yeah.
And I'm very tight with that job. I know the contractor, I know the engineer. Yeah, it works. The MDH, I don't want to say frowns on it. You can get a pump and re-inject passed. It is. Sometimes you need to have more injection wells than pump out wells, and your biggest cost is that drilling. So if I got to have one well to pull water up, and then I got to have 2 to 3 wells to inject it back in, otherwise you get sort of what they call mounding, because you can't push the water back into the ground as fast.
Yeah.
It can sometimes be cost prohibitive. Sometimes it is the right solution. I'm not dogging it at all. You know, and Darcy as a company says their geo, any type of geo, whether it's conventional geo, what they call dipole, that's what we've been talking about here, the dipole technology, pump and re-inject. They're everything geo, but obviously their technology that they lead with is the dipole.
Yeah. Mm-hmm. Well, Bruce, give us some more good information.
All right. Well, we're going to give a few minutes on once we get into the building, and then go on to Inflation Reduction Act and some of the cost of ownership and some of the mechanisms that are within that bill. So we'll start first, bring it into the building. Really anything that can run off water. So centrifugal chillers, water-to-water heat pumps, things that you probably run into every day in your life in commercial buildings that have chillers and boilers, anything connected to those. can benefit from geothermal. Obviously, the best application is when you can apply a heat pump, which gives you the ability to make hot water or chilled water at the same time. That's where you're going to benefit the most. We call those 4-pipe systems. You've got 2 pipes entering and leaving your hot water system and entering, leaving chilled water system to make 4. The 6-pipe system, the other side is connected to the geothermal side of the building. Again, water-to-air heat pumps, you could, in effect, do chillers only, cooling only machines. As Randy mentioned, water-cooled VRF, which we have in our building and many others, usually smaller applications, smaller buildings. And then chilled beam, which is another technology that it uses displacement ventilation. Without too much detail, when you have cold air falling from your ceiling, it displaces the hot air. And since we're hotter than the cold air coming in, all that cold air moves down to where we need it. And we've also got that in our building. And coincidentally, if you can pull 53-degree water out of an aquifer, that's the perfect temperature. You can make a cool building without running any compressors, no moving parts. Ideally, optimizing your building, giving you the best efficiency. And that's really the whole story. I've been doing geothermal for at least 20 years, like precisely geothermal. I've probably worked on over 500 jobs over the years. I'm the biggest fan. That's the reason I'm doing my job right now, because of this integration with Darcy, which gives us so much opportunity here in Minnesota to really do the right thing. A lot of you are probably have somebody you know, or maybe even your house has geothermal. And I wanted to discern the different types of geothermal because it's really important. Randy's mentioned vertical bores. 20 years ago, 30 years ago, there's always been geothermal in commercial applications. You've got to drill down 400, 500 feet, have a U-bend at the bottom, and that pipe comes out, and that's somewhere around 1 to 3 tons. If you're lucky, it's 3 tons. The bores have to be 14 feet apart. You need spacing because it's conductive. We're pushing heat into the soil, into the substrate, and you can't have them too close together, which is a really big problem. So for a school, you might have 2-3 football fields covered with bores. The horizontal application is a lot of residential. You might have a heat pump in your home. Your friends might. They dig trenches. They might dig up your entire front yard. They'll bury it well below the frost line, put a substrate on it, and it's simply a pipe that goes back and forth, returns back in the house. And that's a place for the energy to be stored and pulled from. And then lastly, there's pond applications. There's a lot of those in Minneapolis, by the way.
Yeah.
You got a deep body of water. They sink a heat exchanger in it. You got pipes going in and out of your building. And it works. It's a great heat disposal device. It's kind of hard to pull energy out of it when it's below zero, right? They've kind of been known to change the migratory bird habits, when your pond doesn't freeze in the wintertime.
That one at GRE, and also there's another one at in Rochester at that place down there. They seem to work pretty good for them. Yep. So,
and it's best used for a heat disposal device because you get below freezing, it'll ice up. But you've got to have some chemical treatment. You've got to have circulation in that pond to move the heat around a little bit. And that's why Silver Lake has, 1 million geese in it in the winter, for sure. In other words, things that are exposed to the environment, even horizontal bores, if they're not buried deep enough, can be affected by the heat. I worked on a job in Kansas City where they buried it below a parking lot, blacktop parking lot, and gets really hot in Kansas City, and that overheated the bores. It also matters when you start your system because those three types are a battery. If you start it in the fall, when you're making chilled water in your building, you're pushing all your heat out there all winter. And then let's say your bore field gets up to 90, even 100 degrees, which is a real thing. You've got to pull all that heat out immediately. You could be in big trouble. The way you run your system matters way more with traditional geothermal systems versus what Darcy does. We've always got that 53-degree advective heat rejection device. It's not going to warm up. It's not going to cool off. And also for consulting engineers that have to do this modeling, it is a very, very strenuous model to do traditional geo. You've got to get a special software to do it. You've got to get certified. You've got to do modeling at many, many different temperatures based upon what your building is going to see for load. Again, Darcy, it's much simpler. They're going to give you a number of the capacity of that well at two temperatures, heating and cooling maximums. And again, locally, we're 52-degree. We can figure those numbers out really quick. Now, there might be times when your budget gets blown. You don't need to do your whole building with geothermal. You could shave the peaks off by adding electric boilers or a separate air-cooled chiller, as an example. Hybrid system is what we call those. Randy's worked on a number of those. The budget didn't include enough to go 3-4 more Darcy wells, and they just supplemented with lower cost machines. But the vast, vast, vast majority of those loads can be taken care of by the Darcy system.
I saw somebody made the comment earlier about, we do a lot more heating here in Minnesota than cooling. Depends on the outside air load. You'd be surprised. A lot of your healthcare buildings and bigger office buildings, those are cooling year round. So they'll be cooling in the center, but then they're heating on the perimeter side of it. So you'd be shocked. Actually, they economize, with an air side economizer, probably down to 30-degree ambient.
At least, yep. No.
They're still cooling. So
even commercial buildings in Minneapolis are, especially new buildings, their envelope is tight. They have great windows, but they've got this load in the building of people and computers. Lights, boy, that's gone down a lot because of LEDs.
Yeah.
Yep. I mean, if you ever seen downtown Minneapolis in the middle of winter, you see that big plume coming up. A lot of that's from their cooling towers because they're still actually running their chillers to make chilled water for the district cooling plant.
Mm-hmm. So once we get in the building, we highly recommend that you put an intermediate heat exchanger in, a plate and frame. And I showed a little picture there of how it goes together. There's two plates on the outside with a bar, and you run a number of these plates together. Water goes in, water goes out towards the geo. On the building side, that's the water the heat pumps use. It's good to keep those separate because even typical buildings, gosh, I would say all the way down to Oklahoma, they want glycol in the building, and we can't have glycol in the Darcy loop, at least here in Minnesota. So kind of a graphic image of how these things come together. You need a pump on the geothermal side, pushing and pulling from the Darcy, and what we call a source or sink pump going to the heat pump. Easily controlled. Usually the temperature across that heat exchanger is about a 2-degree approach. So if we're pulling out 53, in theory, 54 degrees would be our best temperature on the other side without getting in the weeds too much. You can put so many different pieces of equipment connected to Darcy. I'm showing a modular heat pump that can do both heating and cooling and simultaneous at the same time. In fact, Rochester, I'm in Rochester right now, but the Civic Center, we had a seminar in April, I believe, and we went down to the mechanical room. It has, I believe, 4 Darcy wells and a modular chiller, and we were not even using the aquifer. We were heating and cooling balance in the building, which is absolutely fabulous performance. No boilers running, no centrifugal chillers, no air-cooled chillers running.
And that's the most
Or
efficient system. If you can simultaneous heat and cool, and that's sort of what I was talking about earlier, if you got, especially with VRFs built systems or even like water to water systems like this, that is the most efficient. It's the best COP. You're going to be running COPs. Everybody talks about COPs with heat pumps, but COP of simultaneous, you're in the upper eights, nines. Bruce
yeah,
knows.
just to give you a balance, the COP is coefficient of performance. That tells you how efficient it is in the HVAC world. An electric boiler has a value of 1. Your best gas boiler might be a 0.9, 0.95 efficiency. At the peak of their efficiency, these heat pumps can do close to 8 times more efficient than your best boiler.
Mhm.
So you can take your gas bill and divide by 8. Now you got to balance that against your electric bill because these are electric chillers in an electrified world. But that's going to win every time when you're, especially if gas rates are at an imbalance to electric rates.
Yeah. And in our market, I used to do energy consulting in a way previous life, but it's about a 2.6 to 1 ratio here of BTU of electricity versus
Your
BTU of
wash,
gas. Yeah, that's sort of our wash point. If you're not at
yeah.
about a 2, at least a 2 COP from
Mhm.
a dollar per BTU to your building, it's sort of a wash.
Yeah.
So,
I wanted to mention the two pipe changeover unit is interesting because there's a lot of old buildings that have fan coils. And these fan coils either do heating or cooling, and they turn them over, if you will, once a year in the spring and the fall. They pick a day and they go, we're going to do heating the rest of the year. And in the spring, they're going to go May 15th, we're going to do cooling the rest of the summer. So just giving you an option, even old buildings can benefit. I wanted to scale this up. So a picture of a heavy piece of equipment, that chiller, the York chiller there, we can cool, we can make ice, do ice arenas.
Yeah.
We can do process cooling, and the biggest consumer of electricity and gas is process. No matter where you go, they're energy pigs, and if we can cut their energy bills in half for a process load, just making hot water, that might be one of those feasibility studies.
Yeah. Hey, Bruce, just to remind you, we got about 10 minutes left, okay?
Oh, perfect. I'll breeze along. Just again showing chilled beam, which really needs 55-degree water, water to air heat pumps, VRF. It is a simple loop around the building and those pieces of equipment piped in it. That's as simple as that. There might be a control valve on it.
Mm.
I'm going to hop into this because this is probably the most critical for money, right?
Mm.
Geothermal is expensive. It's always been expensive. There's been a difference though. There are owners, Minneapolis has, or Minnesota has like the largest congestion of headquarters in North America, like 780 headquarters. And they have green edicts. We're going to reduce our carbon footprint, and their board of directors sign off that this shall be done by a certain date. This is a great vehicle to be able to afford to do that. Now, some even outside of the investment tax credit, which got passed last winter, they moved it out to 2035. Thank goodness. Even some of those without the investment tax credit were and will go in that direction. This just makes it much more simple.
not palatable.
Typically, the number is up to 50% of the design and construction of the geothermal equipment can qualify. Now, that's where Monty Hillman comes in. He's got expertise in driving compliance with this. There's a number of others, Baker Tilly. There's people to reach out to out there that help drive this, and they know it very well. The three components: prevailing wages and apprenticeship. You've got to have apprentices on the job. You've got to keep track, and that's all trades. Even Darcy has apprentices that help spread that out. But it's the pipe fitters, it's the controls folks. Everybody's got to keep track of their apprenticeships, and that's bookkeeping. Domestic content is a bonus. It's sometimes hard to do this because manufacturers have to keep track of who their suppliers are. It's not impossible, but it is difficult. And then the other bonus is an energy community, and I'll jump into what that looks like in just a sec. So prevailing wages, it's got to comply. Apprenticeships, bookkeeping, name of the game. IRS is going to want this. The energy community, they actually have a map, and I put a link on the DOE website. These are places that had coal plants that were shut down. And Minnesota has a couple of green dots up there. And if you click on the location, it'll tell you whether it's in that MSA. And what it's trying to do is re-energize the people that may have lost work. Pretty innovative.
So
you can
just quickly tell us whether we are in the district that it applies for in Minneapolis, St. Paul. Looks like it.
Yeah, if you there's about 4 different zones there. By going to that DOE community tax bonus website, you can check it.
Okay, so you don't know offhand whether it includes the city of Minneapolis or St. Paul?
There are places. I've got St.
So
Cloud.
it's
There's a
broken
little
just.
one right here.
Oh, I
South
see.
Minnesota.
Okay.
Yep,
Got
little
it.
one there.
Okay.
Illinois got a ton. Illinois got a ton of them.
Okay, it looked like it was the whole city, but it kind of in St. Cloud, it almost looks like a huge chunk
Right.
up there. Okay. Yeah, cool. Thank you.
Mm-hmm. I'll breeze through that. All right, this is important. The Inflation Reduction Act, again, it expanded some things. It did not allow for other private entities or groups of entities to pool their money together and get the benefit. It had to be almost a singular owner. Now, they have some limitations. Somebody from China cannot invest in a thermal energy network project. In fact, Rochester's got one going right now. They're putting a system in down there. It is going to be a pump and re-inject, as far as I know at this moment. But the city of Rochester has invested in this thermal energy network. They're putting the piping in. They've got a pump house, and they're going to be distributing in a big circle to various buildings downtown. That job and all of the contacting, piping, labor, equipment that's going in these projects, it's going to be businesses, it's going to be housing. They're all able to leverage the Inflation Reduction Act's credits.
Awesome.
This kind of further defines it. It's building controls. It's the heat pump. It's the wells. It's the labor. I think I mentioned controls already. Some of the others are proportionally eligible. Again, based on the thresholds of what domestic content, eligible locations, and the apprenticeships, etc. So the more you connect, the better it is.
Yep.
Again, just a quick snapshot. We did this a couple years ago. This is comparing a fossil fuel system, a chiller boiler, to a geothermal system. Again, they are more money. Nobody's going to deny that. In this case, it's $1.9 million more for this. So those are big decisions to be made, especially if the interest rates are higher. What it has to do is bridge that time until you can get that tax credit or direct payment. Winona Schools is a great example. They're a tax exempt entity. They got a $5 million check, which paid for the Darcy system and then some. So their total cost is lower than a fossil fuel system.
And they use some of that saving to put up solar, they told us.
Yeah, they put a nice article together on the Darcy website where they interviewed Winona Schools, and they were going to spend a lot of it on capital projects, not maintenance. They were going to build new buildings, which is pretty exciting.
Yeah. Okay.
So again, I'm a big fan of geo. The, the cost benefit analysis absolutely has been done. Are there jobs that don't go? Yes, because of budget. Certainly there are, but it's the proof is out there that this money's real. They are going to get a check later on. Um, I think of tax exempt entities, hospitals or schools or churches or kind of the big one right now is uh, family living. I was part of Minsiva board about 2, 3 months ago, where Robert Ed from Darcy and I joined, and they've got another 15% incentive for low income housing.
Mm.
Another kicker. Um, so that's pretty exciting. I think a thermal energy network, and I'll kind of scroll back to that slide. There's a lot of opportunity for that. One of the big trends 20, 30 years ago when I first started in this, 35 years ago when I started this business, there's a place in Houston, Texas that is centralized cooling and heating for their hospital park. It's 150,000 tons of cooling. The entire city block is built of machines, cooling towers, and boilers, and they're selling electricity to the hospital network.
Mm.
They're making a lot of money because the buildings don't have to put any infrastructure in. They have to buy their energy. This is almost identical. You'd invest in the infrastructure to build this network, and people would buy the energy. You'd put a flow meter, a BTU meter, and however much you use in that building is the utilities the customers would pay with
I have a
no
couple.
maintenance.
Is that a little bit similar to St. Paul District, or is that quite different?
That's very similar, right? They're
Yeah.
selling hot and cold water.
Yeah. Wow. Awesome. Any questions?
Yeah, I have a couple quick ones. Great presentation. I've written at least 10 or 15 stories about Darcy, and I learned a ton tonight. So, well done. For example, one of the things I was interested in, Macalester College. Are you working on that project?
Yep.
And then the school is Hidden River is right, literally a block away. So that seems to be a
Randy,
place where you could almost set up a geothermal network.
Yeah,
right?
yeah. I
Yeah.
I was part of the Hidden River project. There were some learning lessons there.
Yeah, you can talk about that because I was going to ask you about the challenges. I mean, you guys lost a drill bit there,
Yep.
pretty expensive one, and
Yeah.
and
Yep.
the school official I interviewed said they liked the system, but there had to be some readjustments recently for it, as well as Johnson High School, which has a traditional geothermal system. I thought, Randy, maybe if you just want to talk about what are some
Yeah.
of the learnings from the tougher jobs
Yeah.
you've
Yeah.
done?
Yeah. Yeah. That was and basically Hidden River is there's a hidden river below that.
Right.
And the driller basically got their bit stuck. So what we found out, and again, nothing against the driller that was drilling there,
Mm.
a lot of the based on the geology, you can start to, since we're drilling such a big bore, you
Mhm.
can start to get cave in. So it'll cave in on top of the bit. So
Mm.
a lot of the rigs that we're utilizing today are called DR rigs, or what they call dual rotary.
Uh-huh.
And again, I'm speaking out of turn here, or speaking over my pay grade, but they're basically, as they're drilling the hole, they spin in the steel casing right behind it. I'm
No.
not saying you still can't get a cave in, but that's the technology that a lot of the drillers are using. Uh, like 4 drillers here recently just bought GR rigs at the tune of probably 2.5 million a pop, just to help this technology.
Yep.
Because we
That's a
really struggled
vast,
with,
vast improvement.
yeah.
Yeah.
So that driller ended up losing his bit down there because of a cave in. Couldn't get the bid out. They tried for about a month and a half to get that bid out, and finally they just left it there and buried it. So we had to move over and brought in another drilling firm that did have a DR rig, and then they knocked him out. And again, this goes back to the geology thing of we set the wells, started looking at the performance. This goes into the development side of it, like, oops, we need to drill deeper. And that goes into some of that testing and that well development side. Uh, so again, that's some lessons learned. That was some hard lessons learned. I mean, the Darcy never charged the school any more money for it. They said this is on
great.
us. Um, that was my project. I worked with Pioneer Power on it. Angela was part of St. Paul Public Schools. There were some frustrations there. I mean, I never going to deny that, but we're getting through it. Everything is now up and running. I believe the system is running very well, today. It took us a little extra time to get there.
Right.
Have we learned a lot from that? Yes.
Yeah. Yeah.
Um,
Yeah.
Going forward, everything that we've done pretty much here in the last, I'll call it year or so where we've started construction, knock on wood, it's been going fantastic.
The other thing I think this audience would enjoy hearing, and Bruce, feel free to jump in on this. There's this big push by the state, by Excel and Centerpoint. They're, under the Natural Gas Act, they have to do networked geothermal projects, and they're looking for opportunities for it. And Cooperative Energy Futures is also looking to do this more on a neighborhood basis, where they'd have one may say a church would be part of it, and then they would maybe be able to sell to other businesses or nonprofits in the community. And I know a church in St. Paul on Snelling, and it's right near the ice arenas in Highland Park. And I mentioned it to somebody anyway. They said there's too much cooling load to make it happen with the ice center. But from your perspective, I'm wondering, what are the challenges to doing network geothermal, and are you optimistic that more projects can be achieved in the next say 5 years, 10 years?
Yeah, I think there's certainly going to happen. We've got a lot of chatter. Certainly, we hear about all the Minnesota jobs, but I catch wind of a job that's going on in Louisville right now, potentially one in Nashville, where there's big commitments on network geothermal systems and sharing it in a very, very dense downtown environment. So I'm excited. The sky's the limit. Those projects wouldn't probably go if there wasn't an incentive, the tax credits or direct payments. So I'm super optimistic.
Great. We need our own Framingham, right?
I only want to work 9 more years, so let's go. Let's keep going.
We got one more question, you guys. Then we're going to have to pull the plug. Tim, what do you got?
I assume that these systems are probably designed to last like 50 years or so, but the reason I ask is things like irrigation. There's some areas of the country where their well levels, they're going dry. So do you dig deeper in case of that, or is that not a concern around here?
Everything here on the geology side, I'll try to answer as best I can. And again, we're not drawing any water out of the aquifers.
Oh, understood.
Yeah, I live down in Randolph, Cannon Falls, so a lot of center pivots down here, right? And those guys are pumping 600, 800 GPM to the surface on a pretty regular basis, and they all have the MDH or the DNR, I believe, regulates those as what they can pull out of the ground. And I believe they are monitoring, and again, I could be speaking on a turn here, but I think they're monitoring, aquifer levels to making sure that we're not going to over pump our over pump or pump out the aquifers. Now, let's say something were to happen, because yes, you are right. We're designing this for a 50-year plus life, right? And there's maintenance that you have to do to a well. Annual maintenance, like we ohm out the motors. We're building them like a municipal well. So that submersible well pump or well pump down at the bottom of the heat exchanger, figuring 15 years. Now we can service that. We can pull the heat exchanger out, put a new submersible pump at the end of the heat exchanger, drop it back in, and we can do that in probably a day, right? So these things are very serviceable. They're down underground under pressure, so there's no oxygen down there. So there's you don't get any corrosion, like product that's at the surface. when you pull that stuff up, it almost looks brand new. Just because it's under pressure and it's there's no oxygen down there. It's all dissolved. So to your question, if the aquifer levels dipped, similar to like what we had to do at Hidden River, we could pull the heat exchanger, drill deeper, and go into another aquifer if we had to.
Thank you.
Hey, I got it. We got to pull the plug, you guys. We got another meeting coming up at 7:30 with our board. So thank you so much. 1,000 thank yous to both of you. This has been fantastic. Great information. I think we all learned a lot. And sorry we got to cut it off, but like you say, maybe we'll have you back in the fall to tell us more. So
you know, and what could even be better is if you want to have a meeting at our office sometime. You know,
okay.
we're in Golden Valley off of 55 of Winnetka. You know, we have a facility in there that holds, we got a training room that holds 55, 60 people. Just come to our office and have your meeting at our office.
Okay. We'll definitely consider that. That's a good suggestion. Again, you guys, thank you so much. Like I say, we're going to have to cut out for now and switch over to our board meeting. So thank you from MRES and all of us to you. And we'll talk more in the future. Okay.
Sounds great. Thanks, everybody. Take care.
Thank you.
Thank you.
Yeah. Bye-bye.
Bye-bye.